So these three problems represent a particular part of our earlier work that we did back in Unit 3, as I recall, where we saw this particular type of factoring that we could do, but then we used that to actually solve some equations as well. And so we're going to bring this back because later this week we're going to be going into some new lessons that build on the same stuff, but we have to be really solid on this in order to be able to do those. All right, so for number one, if you are starting by thinking about factoring this one by saying what two numbers add to negative 14 and multiply to 49, that's fine. It's still going to get you to the same answer. But in this particular case, it actually follows a particular rule where you'll notice that if I take the negative 14 and divide it by 2, that equals 7, or actually negative 7, right? What's negative 7 squared? 49. It gave us that exact same thing. That tells us that this is what we call a perfect square trinomial. And so when we factor it, it's actually going to factor into something that's squared. Now, if you were doing it with just the add 2, multiply 2 method, the two numbers that add to negative 14, multiply to 49, you might have been inclined to first write it like this, x minus 7 times x minus 7.
Is that wrong?
But we need to go a little bit further than that, because as you're going to see by the time we're done with these three problems, writing it as x minus 7 times x minus 7, it's good, but it's not very useful. It is much more useful if we write this as x minus 7 squared. Because, of course, x minus 7 times itself can be written as it's squared. And you're going to see how we can make use of that here in just a moment. So for number 2, I have the quantity x plus 8 squared equals 9. The first thing I need to tell you here and remind you of is that we do not want to square it out. We do not want to turn this into x squared plus 16x plus 64. That's not what we want to do here. Because what we actually want is we want to have an equation that just has the x appearing once. And you notice if I write it like this, the x is actually appearing twice. That's actually going to mess us up if we try to go forward with that idea. Instead, we can use the square root property. That's the one where in order to get rid of this squared at the start, I take the square root of both sides. So the square root of x plus 8 squared, and that will equal square root of 9, but we have to remember something special at this point. When we take the square root of both sides of the equation, what do we need to remember to include?
Plus or minus?
Yes, exactly, the plus or minus. So it has to be plus or minus root 9 there. So in other words, this whole thing comes down to be x plus 8 equals, the square root of 9 is 3, so it equals 3, and x plus 8 equals negative 3. That's the plus and minus 3. We do one for each. And then we solve it out from there. And that's why we write it as two separate equations, because I got a little bit more work to do. So I now go ahead and subtract 8 from both sides. So I'm going to do minus 8 and minus 8. Kind of running out of room here. So we got x equals 3 minus 8 is a negative 5. So that's one of our answers, x equals negative 5. And for the other answer, again, notice I end up subtracting 8 from both sides. So there we end up with x equals negative 3 minus 8 this time, ends up equaling negative 11. So those are our two actual solutions then. Now remember, in order to find those solutions, I had to have it written like this. I had to have it written as x plus 8 squared, because that's what let me take the square root of both sides. Well, if I take a look at number 3 here, I cannot solve it with it in its current form. I have to change the form on the left-hand side. But you'll notice that this form on the left-hand side, that one looks a lot like number 1, doesn't it? It's very similar. It follows the same pattern. It's that pattern where if I take the middle number and divide it by 2, that gives me 5. And 5 squared equals 25. So that tells me that I'm going to be able to rewrite this whole thing as some parentheses squared. If you prefer to think of it in terms of what two numbers add to 10 and multiply to 25, you get to the same place. You should end up here with x plus 5 squared. And that still equals the 36 because we didn't do anything on the right-hand side. All we did was factor the left-hand side into that x plus 5 squared. Now that we've done that, solving it is easy as the previous problem. It's as easy as number 2 was, right? It's just seeing that critical step that we have to factor it into the parentheses squared first. So go ahead and finish solving that one out. You should end up here with 2 solutions. Basically, every time you're solving a quadratic, you'll end up with 2 solutions. Here you got x equals 1 and x equals negative 11.